This video is on area and definite integrals. So definite integral is when we actually have values at either end of the integral symbol. So you can see there we've got an a and a b above the integral symbol and below the function dx. So when f is a non-negative function, the definite integral gives the area under a curve from a to b. So what that means is between a and b, when we find the definite integral, we're actually finding an area. So you'll see how it works with this example. So write down a definite integral that gives the area of the shaded region and evaluate using your GDC. So A. So write down a definite integral. So we know we've got an integral, and the shaded region goes from -3 to 3 on the x-axis. So that's going to be the values we put at either end of our integral. Now it tells us the function of here is 3 minus the absolute value of x, so it would be 3 minus the absolute value of x dx. And now we're going to put this into your calculators. So on our calculator, what we need to do is we need to go to our menu, go to number 4 for calculus, then we want number 2, the numerical integral. And it comes up with an integral for us. Now we're going from -3, so that is on the bottom, to 3. So our lowest number is always the bottom of the integral, the greater number is on the top. Put in our function, so it is 3 minus. Now I want the absolute value with those straight lines. So on your calculator, click the button next to the number 9. And right at the end here, you'll see the straight lines. So click on that and put the x in those brackets and then put an x at the end. So that looks like what we have written down. Press enter and it tells us the answer is 9. So the area of that shape, that triangle, is 9. And that's how we do a definite integral on your calculator. And so as we just found out on our calculator, this one equals 9. Now we're going to verify this using a geometric formula. So we know that this shape is a triangle. And to find the area of a triangle, we do half base times height. The base of the triangle is from -3 to 3, which is 6. The height of the triangle is 3. Half times 6 times 3 equals 9. So we've verified that they do give us the same answer. Example 2, we want to evaluate from 0 to 12 the function using geometric formula. So what that's wanting us to do is actually just work out the area using shapes. So if you think here, what we could actually do is we could call this area 1, area 2, and then this here is area 3. And if we're going to write it out in integral form first, if we wanted to, we've got the area of 1, which is from 0 to 5 of the function. Then we've got area 2, which is from 5 to 10 on the x-axis. And the final one is from 10 to 12. So what we can do is we can find the area of each of those shapes separately and then add them together to get the answer. Now the thing to note here is when we are adding areas underneath the x-axis, so a negative, we actually minus that becomes minus. So it'll be, this will actually be area 1 minus area 2 plus area 3. Because if we look earlier, what we said is a non-negative function. Now, this part here, where in area 2, is a negative function because it's below the x-axis, so we actually have to minus it. Now if we work that out, the area of the first, we've got a triangle, so it's half, the base is 5, times by the height, which is 4. Now the area of a trapezium, which is half times the base, which is from 5 to 10, so that's a length of 5, plus the length of the top of the trapezium, which is 2, multiplied by the height of the trapezium, which is 4. And the last area of a triangle is half times the base, which is 2, times the height, which is 4, which will give us 10 minus 14 plus 4, which equals 0. So obviously we know the area of this isn't 0, but because we have that negative, it actually counteracts with the positive areas and we end up with 0. So we will look at this later on. You have to be really careful when you're working out areas when it's above and below the x-axis. Now I've got a note here that any region above the x-axis is positive and any region below is negative. The definite integral works out the net area, not the total area. So that's what's happening here. Now some properties of definite integrals. Here, so very similar to what we had before, if you've got an a and a b with how we work it out. Just change the sign when we get to the third one. So if you have going from a to a with your integral, so they're the same value top and bottom, the area is going to be 0. From a to b is the same as a negative b to a. And if we're going from a to b, we could separate into different parts, a to c and then c to b, but the values have to go from a is smaller than c, which is smaller than b. All right, we've got an example that kind of factors in all of these in some way, shape or form. So we've got, given that we've got 4 different integrals here, we're going to find these different things. So the first one, we want the integral from 0 to 3 of 2 f of x plus g of x. So we can separate this into different integrals. So I'm going to pull this 2 out the front at the moment. So with the 2 from 0 to 3 of f of x plus the integral from 0 to 3 of g of x. The integral from 0 to 3 of f of x is this first one here, which equals 5. So this will be 2 times 5 plus 0 to 3 of g of x is the third one, which is negative 6. So it'll be 10 minus 6, which equals 4. B, we want 0 to 4 of f of x. So we've got a 0 to 3 and we have a 3 to 4, which means we need to add those two together to get from 0 to 4. So we've got from 0 to 3 of f of x, which we've been given above. But we want to add that to the integral of 3 to 4. Because then overall we're going from 0 to 4. So this first one equals 5, from 3 to 4 equals 2, so this equals 7 overall. And then C, we want 3 to 3 of g of x, and then 4 to 3 of f of x. So let's rewrite 3 to 3 of g of x plus 4 to 3 is the same as going the negative of 3 to 4. We can swap them around and then we make it negative. Now, 3 to 3, so anything from the same value from top to bottom just equals 0. Then minus the integral from 3 to 4, which is 2. So it'll be 0 minus 2, which is negative 2. D, we're wanting to go from 3 to 6 of g of x. Now we have 0 to 6 and we have 0 to 3, which means we need to do 0 to 6 minus 0 to 3, and that will give us 3 to 6. So the integral from 0 to 6 of g of x minus the integral from 0 to 3. And that will leave us with just 3 to 6. So 0 to 6, if we look at that, that is 10. 0 to 3 was minus 6, which means we're going to end up with 16. And the last one, the integral from 2 to 8 of 3g of x minus 2 dx. Now this is a bit crazy because we look at the top and we go, I don't have any 8s. Now we've got to think about transformations. We've got g of x minus 2. So the first thing I'm going to do is just pull this 3 out the front because we don't need to concentrate on that right now. Now if we think about when we have a minus 2 in the brackets of a function, it translates the graph 2 units to the right, doesn't it? So if we want to get rid of that minus 2, we have to move the function 2 units to the left, which means our parameters will change from 2 to 8 to 0 to 6. So we'll end up with 3 of 0 to 6 of g of x. Because all we've done is move the graph 2 to the right in the original, so we need to move it 2 to the left to get back to something that we would like to use with the x values we want, which is 0 to 6. So 0 to 6 was 10, so it'll be 3 times 10, which is 30.